looks good.
I know the alphabet pretty good.
Not in slow motion either.
No.
Yeah, one time I filmed an entire lesson in slow motion. I don't know, I just deleted it because I was so angry.
You know that you can like change how much
How
is
do
in
you
slow
know
motion?
if it's in slow motion?
Oh,
So you
really?
could just split it, and so only like 10 seconds would be in slow motion.
Oh, man. It was like last
Wait,
year.
what are we talking about? I'm so confused.
One time I accidentally filmed an entire lesson in slow-mo.
That's amazing. That takes up so much.
But Claire just told me that I could have I didn't realize you could like adjust how much is slow-mo. But I just deleted it and refilmed.
That's insane. That was a lot of storage right there.
Yeah, it was. Yeah, it was
Oh, that's a lot.
How do
Okay.
you tell if it's in slow mode?
Say that again.
How do you tell if it's in slow mode?
It says
I press start.
It either
I can't see it.
Oh yeah, I think we're probably
Okay, we're good.
Okay, show me your answer to number 1. Keep it under your chin. For the chemical reaction that's given, which conditions favor maximum conversion of reactants to products?
I know. You don't have to tell me.
I love it, everything.
You don't have
So-
to bully me.
What does it mean in terms of it saying, another way that, or how, what this question is saying,
Oh.
is it wants more product. So we want to do something to the equilibrium that's going to shift it to the right side. Okay, so our options that we're looking at are temperature and pressure.
I think I'm
So
right.
pressure affects by increased pressure to an equilibrium system, which way does it shift?
To the
Fewer moles. So in this chemical reaction, increasing pressure would shift to the product, so that would be a good choice.
No, it's B.
So that means it's
an
either A or
exothermic
B.
reaction.
Okay, so then for temperature, it's an exothermic reaction, which means heat is a product. So if I want more products, then I remove products.
Yes.
So
Right.
B
Let's
is the
go.
right answer.
I had
The math is back
and then I was like,
You know, it doesn't. It takes
What did it do?
Where did we
Yeah, I knew it was pressure, I just didn't know what. I saw that, it was like, yeah.
Let's see.
What
Well,
is
I got the dance, but why is
Low
H?
pressure.
Why, if it's negative, would it be products? Wouldn't that mean
So-
heat is being
Then we're like,
taken away? So it starts on the reactants and gets used up, so the temperature goes down.
So keep in mind it's a change in heat, right?
Yeah.
So if you had a negative bank account, is money going into your bank account or out of your bank account? Make sense?
Yeah.
So negative heat means it's going out of the
Hey,
reaction.
stop bullying me.
Yeah,
I'm
exactly.
gonna report
You
you.
also just go based on like it's breaking bonds or it's forming bonds to make products, so it's like
Oh, good catch, Zach. Yeah, of like the process of what's happening. So that has to be an exothermic reaction. Yes, good catch.
So like, why does low temperature speed it up? Like, I understand like how the equation works, but I don't understand why it actually does it.
So, I don't know if I can explain this.
It's top secret information, sorry.
I'm not allowed to know.
I don't have a good, the words coming to my brain are not clear. So let me keep pondering that question and I'll see if I can answer.
Alright.
That's a great question though. Yeah, because you're asking like the why behind the dance, right? Okay, show me number 2 what you put. It should feel like deja vu because this literally is identical
Yeah, as you
as
said.
we took last week.
Yeah, we literally did the same thing. I'm like, hopefully we all get the right answer.
If you weren't here, I guess we'll give you the benefit of the doubt. But the answer is D.
I put B last time.
Yeah,
Okay.
same.
So the bigger the value for K, right, the more products that are being used. So, okay, show me your answer. Show me your answer to number 3, please.
This is one.
what does it mean?
What is your answer to number 3?
What did 2
Good. Why is the answer E?
This is the Markiplier.
Yeah, where are we at? Up here? So pressure shifts to the side with fewer moles. Well, if the moles are the same on both sides, I get E, then it can't shift it, right? And keep in mind, moles of gas only. So, okay, and finally, show me your answer to number 4, please.
I can do this.
Show me your answer to Okay. So, same thing as number one, we want to favor products.
Oh, wait, no.
Okay.
Dang it.
So, it's not B.
It's C.
Why?
It's gotta be C.
Because it wouldn't shift the
Because you have 1 mole of gas on this side, 1 mole of gas on that side, so pressure has no effect.
Oh, I didn't notice that there was solid on the other side. Oh, that would have made this answer so much easier. Still got it right.
The answer is C.
Yes.
Why are you so luckily smart? You are so lucky. You are so lucky.
Okay, let's talk about why really quick here, everybody. Okay, close your mouth. Close your mouth. So, once again, it's an exothermic reaction. And so for exothermic reactions, heat is like a product. And so if you want to shift towards the product, you remove products because it disrupts the balance. And so it's going to shift to create more. So that's why C is correct. So, any general questions about Le Chatelier's principle?
Why can't we just call it the Chatler? I like that more. Let's start calling it the Chatler. The Chatler.
Okay, so quizzes out of 5. The 5th question, or 5th point,
Please say your name.
is to give your neighbor a compliment.
Your
I like your name.
I like
Why won't you
Okay, slide your quiz into the middle for me, everybody. And pull out your note
Wait,
packets.
do you do it out of 4 or out of 5?
Out of 5. So what's it up?
6 for the name?
What about out of
1
0?
second, he's really slow.
Out of 0.
Out of 0, we just get 5 extra credit points.
I like
That
that.
sounds like a great idea.
5 divided by 0 is
Yeah,
fine.
Except we're not going to
Let's make all of our assignments out of 0.
Well, yeah, but just I know.
That's just my opinion.
That's just your opinion. And,
My
well, I
opinion is-
respect your
Everyone
opinion.
else's.
I don't.
But that doesn't mean I have to
It's
agree.
trash.
His opinion is valid.
I also
Stop it,
Let's
Taylor.
say that the class votes,
I know, but
and
it's
if the
probably
majority
still valid.
says that that should be the case, I think that,
You know that this classroom is not a democracy?
it was worth the
Down
try.
with the monarchy.
You signed up for this, Mama.
That's a good point. Where am I in the social hierarchy then?
You're the jester. I wonder. Yeah, I'm the jester. I'm the jester.
I'll take that. That ain't bad.
Okay, few
That's
announcements,
not me. Am I like?
and then we'll jump in. So
You
pull out
would
your
be
note packet if you don't have it out.
You're serving. No.
You're the top.
No, you would be the accountant, because you're smart.
I don't want to be the accountant. That is so
Yeah.
lame. That is the worst.
You're the guy who counts gold coins all day.
No, but think. If the kingdom. Oh, the accountant. I can argue my way out of this one, but I don't care.
Okay, here we go.
You're trying to argue proves my point more because that would mean you're smart, and so you deserve to be accountant
I don't
more.
want to be the accountant.
Yes, you do.
How many
Okay,
more days do we have?
that's what I was just about to tell you. Thanks for asking that question. Okay, so today is our last day of topics for Unit 7. I
feel
know.
like we take the next test before we're even done with
I
the
know.
text for
It
the
gets
last
tricky because, so like, first semester, all the units are longer, so things get spread out more. Second semester, all the units are a lot shorter, and so we get a lot of, right when we finish, the next one happens, which is happening again. So your Unit 6 test corrections and retakes are due next Tuesday. Okay, if you haven't started on them, please do so soon, so that if you need help on them, you can get help before you email me at 9 p.m. on Tuesday night.
Classic
Because
Wednesday.
there's a chance I maybe will answer your questions, but probably not. Okay,
Yeah,
but
we'll just come in on the last day.
Uh-huh.
Yeah.
That idea.
I'm coming in.
some of you do this, and I love it. Others don't, and maybe you don't need to. But just as a reminder, I'm here on B days before school and after school if you need help on things. Okay? I know that you guys get done with school early, but I'm still here till 2:45. So please, if you have questions, you don't understand things, come get the help that you need, okay? So what that means is on Tuesday in class, we'll be doing our Le Chatelier Principal Lab. And then Wednesday at home day, you're going to take the Unit 7 test.
Wait, what's the lab? What are we doing?
It's like you're actually going to do a Le Chatelier and like see it shifting. So, yeah, because it shifts, it's a color changing equilibrium. So it changes color depending on how it shifts.
Oh.
So it's pretty cool.
Question.
Yeah.
Are those a bunch of wet paper towels or coconut oil?
Yeah, that does look like coconut oil.
What?
Or is it?
And the
It's in a beaker.
It's not.
What is it?
Oh.
Snow.
Don't you know?
It does look like coconut oil.
And wet paper towels.
No, I don't
Wet
see that.
paper
No, like if you just shoved a ton of
I
wet
didn't
paper
see the
towels.
wet paper
Yeah, because I do that.
Is that too much?
That's what I was looking
Snow, yeah, ice, yeah.
I'll show you.
But what-
Okay, time to focus, friends. Okay, shut out your distractions, and if that means you need to pull down your wall between your friends, do so now. Okay? Okay? Okay, so our last thing
Smart idea.
that we're talking about today is still equilibrium, okay? Keep in mind, the more you can connect topics and units, the simpler chemistry becomes, because rather than being all these independent things in your brain, it's just all connected together. And the more you can connect things, the better you are at remembering. So today we're talking about equilibrium for solutions, but it's still just an equilibrium. Someone by raising hand, can you remind us what the word solubility refers to? It's been a while. What does it refer to, Zach? Good, so we're just talking about dissolving things. Have a smiley face for that. So it's not as an exciting equilibrium today because it's literally just talking about something being a solid and then something being aqueous and then being solid, being aqueous, and going back and forth. Okay? So what I have up here that I cut beforehand because it needs a little bit of time is I have made a solution of sodium acetate. So sodium acetate exists as a solid in this jar. Okay, I dissolved it in water to make a solution. Now when you dissolve the max amount of a substance, meaning if I put more in, it doesn't dissolve anymore, that is known as the solution becomes saturated.
Let's play that one game online.
You gotta be more specific than that.
No, it was a vet lab, and like I just played around with it for forever, and I would fill things up, and eventually it would just become saturated.
Oh, yeah, the Beers Law one.
Yeah,
Yeah, with
Beers
shining
Law.
a light through.
I love how concentration was named Beer's Law.
I know, right?
It's just the guy's name.
And that's the thing he figures out.
So, saturated means you've reached the max amount, but the thing is it's dependent upon temperature. Because the hotter something is, the more you can often dissolve of it. Okay? Now what I've created up here just as kind of a cool demo as we're talking about solutions is what is known as a supersaturated solution. So I've dissolved more than what should be able to dissolve in the amount of water I used. Okay?
Wow.
To give you an example, I should have prepared one that I didn't heat up just so you can see the difference. I pretty much dissolved an entire bottle of this, which is about 200 grams, okay, and about, I think it was like 30 milliliters of water.
Wait, so just like weigh a ton?
So yeah, what did it look like when I first mixed them together? Like, it was just like a little soggy, right? But it like was mostly solid. But then by heating it up, it forced it all to dissolve.
Wait, so how much does that weigh?
About probably 200 grams plus.
That's so weird.
So what's happening is as it cools, at room temperature, this much doesn't dissolve in that much water. And so it will start to crystallize back out. Now the cool thing about sodium acetate is that crystallization process happens quite rapidly. Now it's not going to happen yet because we got to let it cool a little bit more. But when it's ready, I'll pause the lesson and you'll see. But we're just going to let it sit there and cool down. And then if we need the snow to help it cool faster, that's what the snow's for.
I found out. I knew that was.
Well, I think the glass is still too hot to put because hot glass and cold things, yeah, isn't it good? So it's still a little too
So
hot.
we
to
should
put
do it right now. That would be even more fun.
See, breaking glass.
Yes.
Honestly, that's a
Do
blast.
that at your house.
My mom
Yeah, but then my mom would get mad at me.
Okay, so with an equilibrium expression for solubility, your equation will always have a very similar format. Okay, where you have your solid is your reactant breaking apart into the ions in solution. Now, we're gonna write an equilibrium expression just like we did before. We have a special label where we put SP, but keep in mind that all K's are the same. So whether it's a KC, a KP, KEQ, KSP, later on we're gonna learn about a KA and a KB. But the nice thing is it's really the same equation. All K's are products over reactants to the power of their coefficient. But then the biggest thing is, what do we exclude from an equilibrium expression? What do you not include?
Pure liquid and pure solid.
Good. So that's what's convenient actually, is with KSPs, the reactant is always a solid, so you don't put it in the expression. So you lose the denominator whenever you're writing in KSP. So these actually become even simpler than the problems we did before because you never have anything on the denominator, because the denominator is always a solid, and solids aren't included. Now, we'll learn about calculating these, but just to give us a number to talk about, the KSP value for this is that's not where I wrote it down. So I just looked it up, 1.08 times 10 to the negative 10. Now turn to your table, buddy, and take a second. What does this number tell me about this process? Ready, set, go.
It says that like
What does that number tell me about this process?
Okay, where do you get it?
I think that's how it is.
Really? So it's like very, very, right?
High five.
Yeah.
That was a crisp high five.
That was pretty close.
You should be proud. You should be proud. That's
That's
your fault. Then.
Yeah.
That's your fault, not my fault.
Okay, I heard it in various ways, but most of you said something along the lines of that it is reactant favored, so write that down. Okay?
That was so your fault.
And in this case, it's like really, really, really reactant favored. Now, in talking about solubility, change this answer in terms of solubility. What does this tell me about the solubility of my?
Very low.
It's not soluble.
Yeah. Low, low solubility, right?
Yay, this is making sense for once.
It is soluble, but to a very, very, very small extent. Because if it's reactant favored by this much, most of it is this. Okay? All right, let's look at a problem and how we can calculate that KSP value. Oh, I forgot about this slide. So this just kind of shows you that a molecular view of what we're referring to of how it's an equilibrium. So we dissolve our barium sulfate or whatever it is. Some of that barium sulfate breaks apart and dissolves. The equilibrium is the fact that the things that are dissolved can come back and become undissolved and bump out something that wasn't dissolved before. Once again, this process we can't see with our eyes. To our eyes, it just looks like a beaker with some salt on the bottom. But at the molecular view, it is constantly changing because molecules don't ever stop moving.
Wait, so if there was no undissolved BaSO4, you could just put as much stuff in there?
Say that one more time.
Because this says some undissolved BaSO4, right? It's like if there's no undissolved BaSO4, it just chills.
Yeah, so if you haven't reached saturation yet, it just keeps dissolving.
Once you're at saturation, then it doesn't matter.
Yeah, so saturation means you've dissolved the max amount that you can.
And then it starts combining.
It's kind of like with salt. Like if I have a cup and I'm adding salt, right? I can add a sprinkle of salt and it will dissolve. But if you just keep pouring salt, eventually it gets to the point where it stops dissolving. And now it's at equilibrium. So.
Yeah. What a waste.
Still too hot. Okay, let's look at a problem. So this tells us that solid silver chromate is added to pure water. Some of the solid remains undissolved, which tells me what?
It's a product. Or
Yeah.
reactant favored.
Good, so I'm at
Equilibrium.
equilibrium, I'm saturated, right, which is important. Okay, we then, just to make sure, we stir it for several days to make sure that as much as dissolvable dissolve. Okay? We then analyze the solution using Ear's law. Okay? And find this concentration of silver nitrate, or silver, sorry, just silver ion. Calculate the KSP for silver chromate. So, first thing, this is our goal, circle your goal. Okay, always know where you're headed. What is a KSP?
It's just a K, but
Solubility.
it doesn't have anything,
Speed.
it's not over anything.
That's okay.
So what's my expression, or how do I write an expression for a KSP?
You leave out the.
Evan?
So would it be algebraic if we have that thing?
Expand, what do you mean by that?
So on the last one, we had the KSP equals, and then we have our two like
Good.
things, and then that equals the 1.3 times 10 to the negative 4.
Perfect, so what we need is we need to know what is this turning into. We have to write the equation. And majority of the times with solubility, they're gonna make you write the equation, but all the equation is taking your solid and showing what it breaks up into.
So it's just 2AG plus.
Good, and
SCR4.
two hydrogens, yep. Now, just a friendly reminder, because some of you are losing points of this on a test, and it breaks my heart because it's the littlest thing.
I hate those. I lost points on the test because of those.
Yeah, you leave the top of charge, it's not the same thing in chemistry. Really close, but it's not the same thing, so.
What? You hit me. For what? Oh.
Okay, now, going back to what Evan said.
Get a bouquet of lollipops.
Of epic.
So Evan, help me out
Oh, I
here, what
see
would be
what
my
it is.
KSP?
Okay, so it'd be KSP equals, and then it'd be bracket
Okay.
AG plus to the second power,
Good,
and then bracket CrO4, and then 2 minus bracket.
that's my case. Okay, so this is what we want. Okay? Whenever you need to find a K value, once again, whether it's KA, KB, all the various Ks that exist, okay, a Rice chart can help you understand how things react at equilibrium. Now, what you'll find is I'm going to set up this first one to show you, get you the understanding of it, but because KSPs never have a denominator, you'll see that, wait, I don't know if I really need a Rice chart because it just comes down to a ratio. But I'm going to write out this first time just to help you see what's happening, but you may find you don't need to make one down the road. Yeah, Gavin?
Is the arrow supposed to go both ways, or is it just the
Ah,
one way?
yes, thank you.
Cool.
Good catch.
Do you use smiley face for that?
I would graciously accept the smiley face, but I understand at this time you do not want me to have a smiley face.
There's a shortage of smiley faces.
Yeah. It's like coins.
Print drought.
Yeah.
Maybe it's bad of me, but when people tell me to give them a smiley face,
I
then
didn't.
I'm less prudent.
Taylor.
Yeah, that
I
wasn't even
told
me.
you to give him a smiley face.
And then he said, I would accept.
Yes. Gavin was only graciously accepting
Okay,
something
you
that I.
can have a smiley.
There
Yes.
you go, Gavin.
Because it was a good catch, so. Question.
Great, now I have to pull my binder out.
Wait, so
And if they run out a little one.
Punishment for graciously accepting
the walls what comes about out.
Okay. Rice charts, let's review. So the first thing is you figure out what just the problem gives you and put that in your chart. So what does the problem tell me that I can plug in here?
The end result of
The 1.3.
silver.
Good. So I know the end result of my silver. Okay? Everything I know I'm writing in black, by the way. You're color coding your process.
When you're like allowed to use, I know this is totally unrelated, but like X for science and notation. But like whenever you're doing math, it's you're not allowed to use an X.
You can just use a dot.
Yeah. It's so dumb. Why don't we just use a dot for science and notation?
You can.
You take the AP test and they mark you down for that.
Okay, what else do I know?
Equilibrium.
Change AG and CO4 short zero.
Why is that?
Because it's just putting in the silver chromate.
Yeah, because all I'm doing is I'm pouring this in, but these don't come out until this starts happening, right? So initially, there's 0 dumps, okay? Now the other nice thing with KSPs and solubility is because this is a solid,
Oh.
none of this matters. We don't have to do anything for that section.
Yeah. Frick that. Get out of here.
Okay, now we can fill in the blanks. So if this was 0 and now it's at that means it increased by that amount.
Oh, just for both.
And as
Oh,
soon as
no,
I know
just
one
for
change,
Because it's solid, bro.
how do I know the other change?
It's half of that.
Why, Yana?
Because the coefficient to silver is 2.
Yeah, so it's a 2-to-1 ratio, so I'm gonna write it like this just to make sure you understand where the number came from.
What
Okay.
is that? 0.65.
And solve that through. Oh, what's that get? 6.5?
Yeah, times 10 to the negative third.
That's squeaky marker. Okay, so then we're gonna plug this in here.
We negative 3 or negative 5?
Oh.
Okay.
That is there.
Oh, yeah.
And then let your calculator do the work.
This wall is so dumb.
Oh. I tear down the wall.
Yeah.
I got 1.1
Oh!
Still stuff in my backpack. Thank you very much.
times 10 to the negative.
fragile stuff in the back?
Well, I don't expect people to go throwing around my backpack.
I didn't throw it.
You knocked it off the table.
That doesn't mean I threw it.
Good point. That is a very valid point.
Got you there.
Remember, Taylor, you have to square it. I shouldn't have to tell you though, as the accountant.
Yeah, I know this stuff. I can't believe you assume that.
No, I assumed you're that smart. That's why you're the accountant.
I totally got the wrong answer. I'm so confused.
There you go.
I literally
You're
just
smart.
plugged it in. Oh, I forgot to put actually square. I literally.
The thing you just told you to do. Questions on this?
And then you go, I'm actually too smart. Of course I did that.
I still got the
Okay,
wrong answer.
try.
Oh, I know what I did wrong. It makes so much sense.
Practice 7.11a with your table then. Ready, set, go.
I got it right.
Once you have an answer, raise your hand and I'll come check it.
Alright, so I said it.
Oh my, wait.
The one that says 7.
Wait. Jamie,
Okay, so
I have a question.
Yeah.
So, can you just, if you have something with that's written in scientific notation, can you just multiply those numbers and then add those together? Because I just was thinking about that, because,
Yeah, you should be able to. You might have to like shift the decimal, because it's all just multiplication, right?
yeah. So I guess if it was like 13, like,
Well, what I'm saying is if like your final answer, it would look slightly different than like what you might see I write. Like, because let's say your final answer was like 12. You don't normally write 12 as part of scientific notation. Yeah.
okay.
But it would still, mathematically, it's still the same answer. So yeah, no, good observation.
Okay. Is that it?
This one doesn't matter.
Okay. Let's write the 2 and 2.
Got the rice chart, we don't have to do that part.
What is the, okay.
Multiply that by 2.
Is that turns into 3
I think we're okay. I think
and
there's.
is this Oxford 8 or whatever?
Thank you.
Yeah.
Alright, wait, let me see.
We don't, I don't know if that's
really fast.
Okay, let's do all H's. Okay, so Okay, so we forget about this, right? Yeah, 'cause it's solid. It's saturated. So then we
I
have
swear to
2.2 times 10 to the 6.
Does it look great?
2.2 times 10 to the 6. And so this one would be times 2,
They
right?
gave us the 2 points.
That one, not times 2.
Oh, it would be this.
That is
Right.
this one.
No, wait.
Yeah.
Oh,
okay.
wait,
That's my bad.
it is?
So,
Is that
Oh,
what you did
yeah,
with us? Did you reverse that? Okay.
Okay. Okay, wait, alright, here we go, second
It's 10,
thing.
I'm correct, it's 10,
Still might be Gavin.
You're gonna.
So just use it.
Why would I?
Let's
Why would I
get
know
it.
this?
One times
I thought they were
Yeah,
pretending.
that's the answer.
Oh, bro.
I'm so
Good, that was my case.
That, right? Oh, but you forgot the first number.
That's right.
Oh, no.
Close.
That's where they're on one.
Is the O raised?
Yeah, and then you just have plus C, plus. And then because that's
So,
Oh, which one had, that's what they, right.
yeah.
So it's all.
the ratio backwards, I guess?
Is that it? 2.0.
Wouldn't that be half of that?
Not quite. Do you remember to square that one when you typed it in? That might be wrong.
it's twice the.
I think your number's like, try that out.
2OH is twice that.
Oh, yeah, because OH, I wrote it down.
Okay, who else needs to be?
Oh, wait.
It's because I wrote the 2.
No,
Wait.
I'm trying to figure it out.
Okay, keep going. We've got some good numbers on the paper.
We just assume that this is, because it's.
Yeah, that's
it's mathematics and it's solid.
So write the case.
For the initial.
Oh, I accidentally just deleted.
Yeah. Or just initially just like whatever you start the reaction, right? So really, most of the time with solubility, you never start with ions. The ions come from the dissolved.
I mean, sure, it
So
helps.
these,
I mean, it helps, which is good.
this value is equilibrium.
So that's happening.
There you go, but it starts at 0. There it is.
Did we, label it? Are there labels to it?
Is it
No
more?
units,
Or
but you
do-
could put like KSP equals that number. But yep, no unit for it. Did you get it?
It's nice
Yes.
having to write
Oh,
units, but
nice.
it's and I know it's gonna mess with me on the 10th. Because I'm gonna be so good.
Oh, yeah, I plugged it in really luckily, but I got it right in.
It was not that I tell you it's the right answer, you asked me. Really? I would tell you it right away. Yeah, that's the right answer.
You know what's really funny?
What's that?
I actually plugged the wrong thing in my calculator. But I have now figured out the right way to plug it into my calculator. Wait, did I get it right? I put the 1/2.
Yeah, but I need it.
But somehow like
Yeah, I don't know how it works.
Okay, I think I checked everybody.
That's how I.
Gavin, you're not like speed one.
People at home, the answer should be 4.0 times 10 to the negative 18. So, okay, any questions so far with KSPs? Before we add just one more piece to the puzzle. Okay, let's look at this next problem here. Okay?
So this is a rice chart, right? We all love rice.
Yeah, actually, the rice is so good if it's white. Brown rice is nasty.
Back to that again.
We're onto this.
What?
Alright,
Yeah, sure.
guys,
It's like
Okay.
a bouquet of flowers.
You get your. Oh,
Take your pencil over here, everybody.
wait, you said that
Three words
orange
is question.
chicken was the best thing to eat with rice.
You know my favorite rice?
What's,
Maybe
is
give them
orange chicken best on rice though, or beans?
Really big sucker.
Cilantro and
Right,
rice.
smart yeah. man.
That is what.
Long lasting
Yeah, sometimes, that one,
Just give
That one. Just give me one, I don't care.
Right.
Really?
Is it like
That's the
the
best
doors?
one.
This is the one I had last
Okay.
time.
More stuff they're landing for me.
Oh, you want this one?
I mean, if you insist.
Oh, is it going?
Yeah, butterscotch.
No, it's not good. It's still pretty warm, but I think it.
Nope.
I think it's cool.
Mystery, mystery's the best.
Mystery, give me mystery. Mystery it is.
Oh, mystery.
Okay, here we go, everybody. So this problem, I'm going to change how it's asking. So I took this as a multiple choice from an AP test, but I turned it into an FRQ just for our sake. So I need to rephrase how it came because how it's written is like a multiple choice. So here it talks about that we have this reaction, okay, calcium hydroxide precipitates when 1 gram of calcium carbide is added to a liter of distilled water. So the reaction given above. Okay, we want to know if that many grams of calcium carbide are used. Instead, which of the following will occur and why? So that's where is the multiple choice. So cross this off. And the question I want to answer is, will calcium hydroxide precipitate? Now let's review really quick. What does it mean for something to precipitate?
I have no idea.
Oh, wait.
Remember
Probably not a
that?
good thing.
Is this to separate?
Flip it.
Oh.
So precipitate means
Oh, I
to
remember.
form a solid.
Oh, yeah, this is right.
So for an equilibrium solubility, okay, so here's my equation. Precipitate means that it is shifting to the reactant side. The reactant is the solid. Okay? So in a different way, this question is kind of talking about that thing of shifting one way or the other based on what conditions you are at. It's very similar to the problems we did last or 2 times ago where we compared Q to K to see how the reaction would proceed. Okay? So what we need to figure out is where we are at, because we already know where it is at equilibrium. It already gave us the KSP value. What we want to take is the given conditions, plug it in for KSP, meaning we're plugging it in for Q, and then compare it. So what we know is I put in 0.064 grams of calcium carbide. What we want to find out is how much of this will make how much of this. We've got to do a side step of some stoichiometry here. So take your 0.064 grams of calcium carbide.
I'll leave that into moles.
Good, so first step is convert that into moles using,
Molar mass.
which conveniently they gave us.
Oh, they did? I was about to calculate it out. Where is it?
64 grams.
Oh, that makes this so much easier. Dude, and those cancel out perfectly. That is so
Oh.
useful.
That's why it was a multiple choice question, because they make the math like simpler. Okay, now I'm in moles of calcium carbide. What do I want to get to again?
Moles of CaOH.
Good, so I want to go from moles of calcium carbide to moles of calcium hydroxide.
Just 1 to 1.
Wait, yeah.
So mathematically it does nothing, but it is always important to make sure you look at that mole to mole step.
So if you don't put that step in on the AP test, will they mark you off?
It all depends on what the scoring rubric says and what they're giving you points for. In the end, if you get the right final answer, you're always going to get the points. The benefit of showing the steps along the way is if you happen to get the wrong final answer, you can sometimes get partial points for good things.
Wait, so if you get the right final answer, but told you the entire thing wrong,
Guess some random numbers.
Like how we plugged it into this calculator wrong?
You really just say guess random numbers.
I literally,
Guesses.
I put something in my calculator wrong, just barely got the right answer.
You're like, this dude's
So let's just say I do that to AP
He's done
test.
spin.
Yeah.
And they're looking at it and they're like, this kid totally did it wrong. But
They'll
somehow he has
probably
the right
think you
answer.
just cheated.
I guess that's where maybe it's, but
So
it
don't show
doesn't
your work, exactly.
No, known to even count big what I'm trying to
Do
say.
everything in your head.
Because then there's more chances where on your guys' test I dock you because you get the wrong answer and you showed no work, so you don't get any in between points. I don't think though, Taylor, technically if you had the right answer somehow, but your work,
Will they like what happens if they like assume a cheat? They're like, there's no way this kid got the right answer. Just
I'm assuming if it happened like every single problem, then they might, you know. But
okay.
if it just happened once,
Now I know how to cheat. Perfect.
How would you do this?
Yeah,
No,
you get
I'm
one more.
I'm not planning on cheating. That was a throwaway joke comment. You know.
no, that doesn't make any sense. It's not going to work.
But like, if worse comes to worse, if he showed his work, they could just plug in the numbers and find out that makes the same.
Yeah, that's true. But like, couldn't I work backwards at that point? Couldn't I take my number and make some random thing up that made it work?
You know that this test is timed, right? Okay, all I'm saying is don't listen to Taylor's logic and we'll fight. Okay.
Yeah, don't listen to Taylor.
All right, so
Finally,
this is
someone agrees with me.
1 times 10 to the negative 3. Okay, so this tells me how many moles of this were created from the first reaction. So this is like a two-step reaction. The first reaction is making this. The second reaction is this starts to dissolve.
Oh, I was so confused. That makes more
Does that
sense.
make sense now?
Yeah.
Okay,
Oh.
so what we want to know though, so let's write our KSP, or what the expression is. So it's
Risk.
calcium.
But there's no R, dude.
That's okay, just imagine one.
And it equals 8.0 times 10 to the negative 8. So equilibriums are always going to find their way to equilibrium by shifting whichever way they need to go. So what we're going to do is we're going to plug in what we know we're at and see how it compares to equilibrium's value. So once again, we're just going off ratios here. So if this is the amount of this, and this is a 1-to-1 ratio.
So then that's not that hard.
So this is the same as that.
So does that mean that that's just the same as that, but like 2 times? Or 1/2?
Oh, we're gonna have to.
Oh no, it would be, so this is a 1-to-2 ratio, so this would be 2 times because of the ratio.
Okay, wait, so it just 1 times 10
So now plug these
plus
into the expression. So we have 1 times 10 to the negative 3 times what? 2 times 10 to the negative 3 squared. So that gives you what? 2 times 10 to the negative 9, I think. Oh wait, no, 4 because it got squared.
Yeah.
Now what's significant about this is what we label as Q because it's not at equilibrium or we're not sure if we're there yet. Now, it wants to get to here. So first off, I'm not at equilibrium because it didn't equal that. So did I go too far or am I not far enough to get to equilibrium?
Too far.
Is this greater than or less than K?
Less than.
So Q is less than K. So which way will my reaction proceed to get to equilibrium?
To the CaOH. Wait, I did that wrong.
Yeah,
To the product side.
So if Q is less than K, that means you need more products. And are my products my precipitant?
No, yeah.
No, not in this scenario.
No. So it will precipitate.
No, so the answer is no, it will not precipitate. Because the reaction is
Oh
going
right, I
to-
forgot that's not precipitation.
Oh, there you go, yeah.
Okay, yes,
So
got
this
it.
is not precipitation, this is precipitation. Right, so the answer is no, it's not going to precipitate because it's going to dissolve more ions to get to equilibrium.
Yeah, for some reason I just thought precipitating was going the other way, and I'm like, so it will.
Someone did the same thing last period too, where they just reversed the definition.
The trick is you just throw out words until you get the right answer, not make sense for it.
No.
Yep, that's the way to do things. questions on that question? Okay, turn to your table, buddy, and play rock, paper, scissors. Gabe, you can do like a triangle with you, the people, how you the people in front of you. Okay, ready, go play. Rock, paper, scissors, best 2 out of 3.
Yes! Victory!
Oh, we're gonna get
Alright, that's paper game. Let's just go first.
I got crushed.
Okay,
Okay.
you think when I say that, people
Gabe,
will
let's just give it to Gabe. Alright, Gabe wins.
play?
What did he win, a smiley face?
Okay, raise your hand if you're the winner.
Throw it.
Raise your hand if you're the winner. Okay, if you are the winner, you are now going to take 60 seconds and be the teacher to your buddy and teach them how, walk them through this problem start to finish. Ready, set, go.
Alright.
Here we go.
I'm not your TA.
Start out with
So that tells you how much
Use the ratios of that equation
and then
to
so everything
you
changed it to
left or right.
so then we could convert them to so we could change this to that.
Right?
So the 1 ratio, you know?
and then you put it into our
We had to change this to 1. So we got like 0, 1, 0, 0, 1.
And that's what
And then we have to change that to 1 ratio. It's just 1 more.
and you add
If we got the answer,
add
you know, times the negative. Or
that
times the
is
negative.
less
And then we
than
plug that into the
this.
equation.
Just
So
for
we
fun.
know that
One
it
to 2 ratio.
Yeah.
So we multiply
it's
that.
gonna have
Square it.
No, actually, no. We learned about
So like, so basically this one.
Let me just add that. So then like on those tests, you're like,
What is it?
that's why you're not get it wrong.
Yes, because to get a bigger K, you need more product,
And
right?
then,
And the product might not be the percentage.
Like I understand.
yeah,
I like
Why would
trying
someone
to
like you double it and then
but then I
split.
also
Once you get to that
Kind of
point,
weird.
at
then
one point
I guess, because I guess one is the
That makes
ratio
sense.
and the other is
it went from like
what is minus?
kind of weird.
America
but
And then
Crazy,
multiply
yeah,
that,
those tiny little magnets, very dangerous. Probably shouldn't be doing that. Yeah, probably because I have baby.
Exactly. So we just gave them
Anyway, some people, back east,
No.
be like,
A bunch of mega straws be like, here's a map to the capital where you already know to get to. You're welcome. Blink flies off in this Black Hawk. It's a bunch of
like
Nerf
30
guns.
something.
oh my god.
Yeah, and he didn't tell his mom for like a few days,
Wait, what?
because he thought it would be fine, like,
Wait, what are we talking about?
we were talking about magnets, and this kid ate, don't eat magnets.
Oh yeah.
He ate a magnet?
No, so those little tiny bead ones,
Yeah,
he ate
the
like
lucky
30
ones.
something of them.
No, and you died.
Because he was curious, almost. Yeah, it was like really bad, because once they get like down into your like intestines and
Intestines, they
stuff,
stick
like,
together.
yeah, scary.
Hands down on your intestines.
What a
Yeah.
guy, dude. Why would
But he
ever
thought,
do that?
he wanted to see if he could be magnetized to his stomach.
No, oh my lord.
Yeah,
I
until it
really
rips
broke
through
my
your.
No, that
So
would
it's
be
like,
so
I don't know, he's like old enough to know not to swallow things. So I guess not.
The dankness of this
But
guy.
apparently he's gonna risk
The
it.
dankness.
Imagine walking by your
Is it guy?
That's like his 6th grade science project. He's like, I ate magnets.
I am now
I am now
magnetized.
Polly,
It's like,
I am now
it's like,
magnetized. I was magnetic, but did it cost me my life?
Flying walls.
Almost.
Get magnets in his
Would
ear.
I
And he's
recommend?
just like,
oh, but dude, I'm trying to
If
stick a
you
magnet
want,
next to his
yeah.
stomach. It'll clamp down on all that
yeah,
fat.
think that.
Oh,
that's
that's
not
so painful.
Okay, last thing everybody, and then I think our supersaturated solution will be ready.
I love that. It's an alliteration.
It is a good, it's fun to say.
Super saturated solution.
Oh.
Okay, so
And then they tell them.
common ion effect, okay, is a new topic, a new thing, but it honestly is just Le Chatelier's principle with solubility. Okay, so if you want to make a little note to yourself next to common ion effect, it's just Le Chatelier's principle.
I can't spell it.
Okay,
Oh my god.
just the dance.
It literally
Wait,
says-
do we have a
I
test
know.
coming up?
So, what we're talking about here, okay, let's use our saturated solution as an example, okay? If I have a solution that's at equilibrium, and then I add something to it that's part of the equation, it causes it to shift. Well, the same thing can happen with the solubility, but it just is a specific ion. So let's look at this problem to get, it'll make more sense once you see it. So here's my equilibrium equation up there, okay? The problem says that I'm going to add some sodium chloride. Now sodium fluoride is 100% soluble because it has sodium in it. Remember, all sodiums, potassiums,
Nitrate
nitrates,
and ammonium.
there you go, are always soluble.
Oh my god.
That was your fault.
I'm gonna just bring this down.
Sad high five was your fault.
Yeah, I know. I'm so mad at high fives, man.
Chris.
Remember that?
Someone told me to look at an elbow.
Yeah, you look at their elbow.
And you'll never miss.
Yeah, but then if you look at their pinky, it's like very difficult. Have you ever done that?
Here, wait, let me try.
Yeah, look at my pinky.
Oh,
See how
that's so weird.
See how off to the side?
Oh, yeah, that was
the
way
crispest
better.
high five of your
So
life, though.
much
What the
better.
heck? Wait, did you look at my
I'm
elbow?
always totally looking at your beat.
Okay.
With the elbow.
So, what we're saying here, everybody.
Hey, Chris.
That was my distraction.
Alright, I figured it out.
Trying to have characters high five me. Okay, so this is my equilibrium. Okay, I'm adding in a completely different salt, but that salt shares an ion of fluorine. Don't say your answer out loud, but for one more smiley face today, if I increase the amount of fluorine, point with your finger which way the reaction is going to shift. Don't say it out loud.
There we go. Yep.
Yeah, did it. See, Winston did the dance too.
The dance.
It works.
Are you gonna show that to all your future classes? You need to. It's good for the soul.
No, I really like it.
It's actually kind of fun.
Okay, if you're pointing this way, have a smiley face.
Yes.
Great, I have to get my binder
The
out.
common ion can force something to precipitate. So if you want to precipitate something, you can add a common ion, and it will force this to become more, right? Because you're shifting the equilibrium.
Fun stuff.
But that's really the common ion effect. It's just adding something. So I guess let's put some words to our answer here. So it says, explain the effect of the addition of NaF. So by adding NaF, we are going to shift to the reactants.
Right, you should be.
Resulting in more precipitant.
Wait a
How did you
second.
pull that off?
Yo, Landon.
What? You're like the best student ever.
He has more smiley faces than Taylor.
But you're more smiley faces.
That's true, but if I say me, that doesn't sound as impressive as Taylor.
Cause that
You know?
was me, Greg.
Yeah, exactly.
Okay, questions on the common ion?
These are all.
Yeah, Isaac.
What's the difference between doing the two half arrows and the one that the arrow that has both directions?
Nothing.
So then
This
you
is
have-
like the more
Science.
Wait.
sciencey way to write equilibrium, but
What is that?
the other way is the way my computer types it. Because the computer program, Google Docs doesn't have this as an option. So like on your worksheets and things, I typically do the other one. But this is the actual like official equilibrium symbol, but they can be
I think that
used
one
the
looks
same.
so much cooler too.
I think so too.
It's like, it's an equal, but like one's going this way and the other one's going this way. It's like,
I think
So didn't like doesn't the equilibrium sign that you do wasn't that like electrons inside of like
oh yeah,
thing.
sideways.
Oh, yeah, it is.
Yeah. Yeah, you're thinking back to orbital diagrams, they were also half arrows.
yeah, and then like when there was two.
oh, I remember those.
Yeah.
Oh.
Yeah, so it's like, those are like, yeah, good connection. So,
Actually, I don't remember those. I have no idea.
now, your homework, everybody, I really tried to simplify it so that you have more time to work on test corrections. So you have one worksheet, it's like 3 problems, that's it. It's not very long at all. Okay, there are, I forgot to write it down, you do have a few pages of reading just about what we talked about today, solubility, and then I took off the AP classroom.
Hey,
What's the
pages?
Hey, does anybody
Okay,
actually like?
so hopefully that will give you some more time to get those test corrections and things taken care of, okay? Okay, let's see if this is ready.
Wait,
Melted
did we
all the
do any
snow.
Unit 7 labs?
Next time is our lab.
Oh.
Wait, what are we doing on Friday? Are we starting next Friday?
Today is Friday.
Oh,
next Friday.
Because I'm not going to be here next Friday. So that works.
Wait.
Okay, so we are to the point, so it's super saturated, remember, so there's way more in there than what should be at the temperature I've cooled it down to. Now it's all still liquid because of just the way the molecules are right now. But if we agitate it, then as soon as one crystal comes out and turns into a solid, it's like a domino
Isn't
effect,
this
they
like
all
how
start
those like
latching on.
water bottles work? Like where like
Kind of a same
you
concept.
bang the water bottle and it's like
Yeah, I mean, it's not, it's kind of the same.
This
It
is
looks the
cooler,
same.
Taylor.
Okay, so now there's 2 things I'm going to try. One is if I just pop the lid off, sometimes that will start the reaction, start the process. If that doesn't work, then I'm going to add a seed crystal, so like 1 grain, to give them all a starting point to latch onto. Okay?
I don't know, maybe it's slow-mo would look good.
Slow-mo is really
I'm gonna
cool.
go.
Let's get it.
I was going to bring it around. Does that help? Or you understand that?
wait. Here, just make sure not to be in the way.
Yeah, you're in the way of the camera.
You guys, oh yeah,
Yeah, online students
Okay,
need
how
to
about
see.
one of you
that
film
makes
and the other
sense.
share?
Great. No, this is so sad.
Okay, come on this side though, Landon, so everyone can see. I was also going to grab.
I accidentally submitted my English assignment to your. So sorry if you get that.
Is it, do I need to make more submissions, or is there?
No,
I do that every once in a while,
I
someone will say,
submitted the
like,
right
that's-
one now. I just was.
There we go.
Oh, it started.
Wait.
What?
Yo, it's like
Whoa! Whoa!
It's like the.
What the heck?
It's like an avalanche of death.
It looks like something in
Now it's
reverse.
pretty cool
It's so
because it's
bad,
quite
guys.
exothermic as it solidifies. So if you feel it, and it'll get hotter as it sits.
It
So
looks
they
like
sometimes call it,
Like,
they
when it
call it
gets all
hot
busy.
ice.
Reverse ones.
So like it
It's
looks
so
like ice,
cool.
but
That is so
It looks like
cool.
when you freeze water just enough time and you hit it, it freezes all.
Oh yeah, it's like really white. It's like-
so that shows you how much solid versus liquid. Right, so
Wait.
there's the liquid
What?
What the
that I originally put in.
Very straight salt.
That is so weird.
Pretty much so.
Salt.
So other people do this, they just don't do it as
Straight
quickly
Scott.
as like.
I thought it was really cool.
Weird, huh?
I thought it was like ice.
Yeah, it looks like ice. What the heck?
Yeah, so they actually have little